Good morning to you all. A warm welcome to Coventry University and indeed to this first car day. Thank you for joining us to celebrate, as we do, the car, Coventry City and its associations with the car and the university. All of us, in our separate ways and intertwined, have, I think, contributed to the history of the car, stretching back over a century now. And today the history is all around us, literally, here in the city centre. And of course, parts of this university were built on factory sites connected with the automotive industry. And we have named our buildings after some of the great automotive marques, including Morris, Lanchester, our library is called Lanchester Library, Jaguar and Armstrong Siddeley. Now, Coventry became Britain's Motown, the motor city at the heart of the car industry. And many of the most famous of models were produced and put into production here from the Triumph Herald. And I think I'm right. I think I've seen one of those just coming onto the car, onto the square this morning. Of course, the iconic Jaguar E-Type, which again also built here in Coventry. And we had factories at Browns Lane, at Banner Lane, at Stoke Aldermore, Canley, Holyhead Road. The list goes on. Lots and lots of places in this city associated with the car. And you'll see some of those cars today, both old and new, proudly displayed in the square in front of the university, between the university and the cathedral, but also all round our campus. And of course, you can also visit some of those places on foot if you wish, or by minibus tour a little later in the programme. I think the university, and before we were called a university, Coventry Polytechnic, and before that Lanchester Polytechnic, or the Lanch as it's known, I think affectionately by many of its alumni, played a full part in producing engineers and designers. Engineers such as the Formula One aerodynamics expert John Eiley, designers including Jeff Upex and Jerry McGovern, and more recently we branched into automotive journalism. John Quirk, the editor of Auto Trader, is one of ours, and of course today the editor-in-chief of Autocar, Steve Cropley, who's a visiting professor here, is also today speaking and is one of our honoured guests. So we're proud of being part of Coventry's auto past and present, and we intend to take a very full part in its future through the courses that we run, both in automotive engineering, and we have people from those courses speaking this morning, also, of course, from automotive design, which is world famous, and from automotive journalism. And we'll start the symposium today with some of those eminent speakers and introduced by our Chancellor, Sir John Egan, himself, of course, a major contributor to the car industry in this city. The Bugatti lecture will be in here at 1:30, I think. Check that time. And that's going to be given by Sir Nick Shaler, who will be known to many of you. And then at 3 o'clock, we have a Coventry car question time. We're hugely grateful to Peugeot UK for their support of the symposium today, which has meant that we have been able to bring this day together through their generosity and opened it to the public across Coventry and Warwickshire, which is pretty much what, as a university, we always try to do, to open up our expertise and the things that we're doing to be shared more widely. There'll be lots of other things to help you celebrate the day today. The square, the University Square I've mentioned. The Herbert Gallery is running a special display on the car history. There's a careers fair here about the automotive industry. The tours I've already mentioned. And finally, Evensong in the cathedral with an automotive theme. I think that has to be a first on any cathedral in the country. And we're delighted and very grateful to the Dean and Chapter that they've entered into the spirit of the day in that way. So do join us today in the sheer joy, I think, of celebrating the car and everything to do with the automotive world, the first Coventry Car Day. I think Britain's Motown still lives, breathes, and is hugely energetic and vibrant. And that's my pleasure to hand over to Sir John Egan to introduce the speakers.
So thank you. Thanks, Madeline. And welcome to this symposium on the future of the automobile. where we hope that with a clean sheet, think tank approach, we can help in solving the extraordinary problems now facing the continued growth of the automobile industry, problems presented by CO2-generated climate change, now being accelerated by the explosive growth of wealth in the Far East. So imagine, for half a day, we are the board of directors of the world car industry. And we're going to see whether we can keep this industry growing in spite of the fact that we have this huge problem of curbing CO2 emissions. I'm going to set the scene by describing some of the problems we face, some of the inertia the industry's got, and how difficult innovation is in this industry. Anyway, you could say that Coventry and this university have been in on the industry and industrial design from the start. Integrated industrial design commenced, the theory of it commenced at this university in the 1880s with the textile industry. And cars were first manufactured in the city by Daimler in 1896. So we've got a long history in industrial design, and we have a long history in the car industry. This modern university has a center of excellence in product and automotive design, and it's always been closely associated with the industry. Many of the early pioneers had premises close by, including Lanchester, a model of which I used to drive in the Brighton Veteran Car Run, and I'll come back to that later. That company gave its name to the original Lanchester Polytechnic, which became Coventry University. We offer the widest range of automobile research and teaching anywhere in any university, covering the fields of design, engineering, business, and media. Students from our courses have been graduating into leading roles in the industry worldwide over the last 50 years. Okay, now let's first of all look at the industry itself. The car industry is one of the largest, most successful, therefore competitive industries in the world. It carries a huge amount of inertial baggage, not only of expertise and excellence, but also inertia because of the huge resources required of a car company just to survive. Thus, the board of directors, and that's us, doesn't have a clean sheet of paper. Occasionally, startling innovation is possible in spite of all of that. But let's have a look at what are we doing already. Well, to survive, you've got to achieve something like 5 to 7% improvement in technical capability and cost improvement. And you've got to plan for this, for yourself as a car company, but also the integrated supply chain of probably 500 or 600 other companies. This is a tremendous effort that is required simply to survive. Most industries find it very difficult to make any improvements at all. Well, we've got to turn in 5 to 7% of things better every year. Annually, there's rafts of legislation appearing to improve the safety of passengers, other motorists, passers-by. We have to improve our gas emissions of CO2 and other noxious gases. We've also to improve our noise performance, not only within the car, but also for passers-by. Also, the car is a styling statement as much as any fashion item, and it's subject to the vagaries of customer choice. By the way, nobody wants to buy an ugly car, so you're going to have to really think about it very carefully. When you're innovating, don't make them ugly, because actually that's very difficult to sell. Fuel economy is important, but large luxury cars have always made more money than fuel-efficient cars. The hugely successful BLMC Mini never made any money. So they made a lot of them. At one stage they were making 500,000 or 600,000 a year. but they didn't actually make any money out of them. So be careful. Fuel economy doesn't necessarily make a lot of money. Also, service is given at the point of contact with the customer by hundreds of independent businesses. I mean the dealers. These are very independent-minded people. And they're fickle or they're loyal depending on your constancy of purpose and product integrity. A sudden change of direction is very hard to manage, and it's fraught with danger. These guys have invested a lot of money in their dealerships, and often they're in just the right place to sell cars. And if they're not selling our cars, they'll sell somebody else's. So it's very, very difficult to change direction. Also, the design process of a new model is one of the most complex design requirements required of human ingenuity. Hundreds and hundreds of millions of pounds of capital expenditure and 4,000 or 5,000 man-years of engineers' efforts, your own engineers and your 500 or 600 supply chain. It requires a huge amount of effort to bring any change into this industry at all. When I was on the Brighton Run, I often used to look at all the various shapes and sizes of the various cars. There was a huge explosion of innovation going on. I was driving a Lanchester with tiller steering, rear wheel steering, by the way, with a tiller, and it was a pretty frightening thing to drive around. But I used to look at this 1903 Mercedes-Benz racing car, and I used to think, well, things haven't changed much from there. Mercedes-Benz had more or less got it right. There it was, 4 wheels, front wheel steering, rear wheel drive, brakes, proper brakes, brakes front and back. The thing was back basically car, more or less, as we'd recognize a car, and probably we would recognize how to drive it today. So these things intended for personal transport have a difficult interaction with the human being, and changing things is now quite difficult because we've got a lot of history plowed into them. You know, it's still possible to innovate. However, innovation is dangerous for car companies. Everybody remembers the Ford Edsel. BLMC, by the way, in its, I don't know how long it was alive for, but it didn't really bring a successful new model to the market at all. So they were working for about 15 years using mostly government money, but actually they didn't innovate successfully at all. They couldn't bring new products to the marketplace. There have been successful innovations. Obviously, when the motor car industry started, people were trying all kinds of different things. Steam cars, electric cars even, internal combustion, diesel, all kinds of things were tried. Front and rear wheel drive, tiller steering, steering wheels, and in the Brighton Run you can see them all. And then a course of action was taken. There's been some innovation since, and you can innovate. The Volkswagen Beetle was a terrific innovation in the 1930s. The Mini itself, the Land Rover, was a serendipitous innovation, brilliant actually, and was the creation of a successful company. And recently we've seen the Toyota hybrids, and we've seen the Nissan electric car, and we're seeing things like the hydrogen cars, fuel cell cars, but nobody is putting them into the market yet. Ingenuity is required, huge resource, serendipity can produce innovation, and one of these might be the way we go forward, one of the things that's already there, or it might be something different, because I'm going to try and explain the scale of what we have to do as we go on. So we've talked about the board of directors and what it's doing and how difficult innovation is. What about the customer? Well, the customer has learnt to build his or her life around the car for going to work, going to children to school, shopping, recreation, holidays, and so on and so on. Planners have also learned to zone cities so that retail is in one area, businesses in another, houses are in another. So you need your car to go to all of these segregated activities. Often they're enshrined in the planning laws, such that many of the old beautiful medieval towns, and I live in Warwick, you couldn't actually create Warwick today. It wouldn't be allowed to have all these multivarious uses all in one place, because it wouldn't be safe for people or for the cars to have cars whizzing around in medieval streets. And yet Warwick's a lovely place to live, but you couldn't build it again today. Another problem, heavy goods used to be distributed by rail and were thus segregated away from passengers and passenger cars. But you know, with the sort of decline of the railways in the 1950s, that really isn't possible anymore. And we have huge 40-ton trucks mixing with our cars. And this is a nightmare for the safety engineer. How can you safely mix 40-ton trucks doing 60 miles an hour with a car expected to do 50 or 100 miles per gallon? What kind of way can you do that safely? By the way, trucks, 40-ton trucks, stop very slowly compared with a car. And so you'd have a lot of space and room. And they do make a mess of a little car when they hit it. What are we going to do about 40-ton trucks? What are we going to do about zoning? Because actually, it's rather a shame that we have to do all of this by car and by road. But anyway, at the end of this 100 years or so of the car industry, we've got almost as many cars as adults in the developed Western world. They each average about 10,000 miles, and the average of the car population in the world is about 25 miles per gallon. And I'll stick to emissions in miles per gallon terms just to simply make it all comparable. In any way, they're the only numbers I can remember. So we've got cars doing about 10,000 miles, and they've got to do it like that because cities are zoned and you've got to move around using your car. Each one does about 25 miles per gallon. Together, all of them produce about 30% of the CO2 generated by fossil fuels. So a big part of the whole CO2 problem is now mixed in with our transportation problem. Now, what have governments... No, I'll just say one further thing. Today's developed world of, say, 1 billion people will grow to, say, 4 billion by 2050. Because by then, we'll have a fully developed China and India, each with about 1.25 billion people in them. We'll have Indonesia, Brazil, Nigeria, by the way. A lot of southern Saharan Africa will be developed. All of them will want to be having cars, and so we'll be having to sort of cater for a modern world of maybe 4 billion people. And the target is to halve emissions from where they are today. So the target is to halve emissions, and we'll need 4 times as many cars. So what does that actually mean? Well, we could do 100 miles per gallon for the new car, and we'd halve the mileage by better city design, doing away with all these zonings and separating trucks and cars and all the rest of it. Maybe that's one way of doing it, by simply having our target 100 miles per gallon and halve the mileage from 10,000 miles to 5,000 miles, or by just improving the fuel economy alone, we're going to have to set a target of something like 200 miles per gallon. So the average today is about 25. We're going to have to get up to about 200 if we're going to really answer the problem of CO2 emissions. Oof, how are we going to do this? Well, luckily, we've got some of the experts of the industry here to tell us their ideas of how they're going to do it. So some of them will be talking about design, some will be talking about design of cities, some will be talking about the way we'll have to change consumer behavior, the way we're going to have to talk to people, how we're going to get them to think about it, how can we get these city planners to plan more better arranged cities, how can we get cars which can do 200 miles per gallon mixing in with 40-ton trucks. How are we going to do all of this? Well, luckily, we've got the right people here to tell us, so let's get started. Now, who's going to be the first one to get us started? Thank you.
Yeah, sure.
And if you just pop that in the pocket.
Right, okay, which is the switch?
Oh, it's already on. Don't
Okay,
worry about
okay. If I can introduce myself, I'm Martin Woolley, and my role here is Manager of Research for Coventry School of Art and Design. And I'd first of all like to thank Sir John for an admirable talk, which I think perfectly sets the scene for today. It's going to be an exciting day, and I think the big hope, and you're hinting at this, is that we have a run and a sequence of conflicting opinions. I think that's what we're hoping for here, and maybe some reconciliation later in the day. It is my great pleasure to act as chair this morning and to introduce the 7 speakers that we're planning to present to you. We've got an excellent lineup, and they are drawn from many different but overlapping fields, including design, engineering, automotive journalism, business and industry analysis. Some are actually academics based here at Coventry University, and others are very welcome guests. And all of them have been invited to address the subject of the future of the car. I think this is as distinct from the car of the future, because the car of the future, as many of us here will know, is our comfort zone for dealing with difficult issues, but it's also kind of narrowly self-defining. So our speakers have got a much greater, more impressive challenge to get underneath that and really talk about serious issues and the real challenges and exciting propositions ahead of us. The programme's in 2 halves. We'll take a 20-minute coffee break around about 11 o'clock, and we'll reconvene then for our final 3 speaker sessions and wind up somewhere between 12:30 and 1 o'clock. The key to this, and the VC has already mentioned, that there will be a question time at 3 o'clock this afternoon back in here. And as we're going to run the speakers end to end, there won't be time for debate this morning, so the real focus is in the question time. So I would hope that as many of you who are here now can actually come back after you've had a good tour around, make your way back here for the question time this afternoon. We will be reconfiguring the space in the meantime, and some of our presenters and others will be forming a panel at the front here. So it'll be your chance really to fire back. So, without further ado, I'd like to start the proceedings. Our first presenter, who couldn't actually be here today because he's a ubiquitous presence in the media and is always, really, as far as my experience is concerned, a virtual presence. So it's David Bailey, who is Professor of International Business Strategy and Economics at Coventry University Business School. And he is a regular commentator on radio and television any time there is a controversial topic to do with industry and the motor car. His talk's entitled Drivers of Change in the Automotive Industry, and change is obviously his watchword. So he's going to explore changing production patterns, changing technologies, changing labour needs and changing demand patterns, and this will include reference to models of ownership and mobility. Thank you very much.
What are the areas that you think are going to change in the future of motoring?
Well, I think the 4 big drivers of change in the industry are changing production patterns and how companies cooperate with each other and with their suppliers, changing technologies, the technology that goes into cars, changing labour needs, the kind of skills that workers need to put cars together, and finally, perhaps most importantly, changing demand patterns and changes in consumer tastes.
So what are the changes that you see in production of cars over the next few years?
Well, we've seen already a shift away from the old Detroit going south in search of low labour costs to southern United States and Mexico. In Europe, we've seen, for example, Peugeot closing in Coventry and going to Central and Eastern Europe looking for lower labour costs. So we've seen a shift towards lower labour cost locations. But we're not necessarily seeing a pure model of globalization take place. It still makes a lot of sense for car companies to produce near the end market. So it doesn't make sense, for example, necessarily for the Japanese and Koreans to make cars in the Far East and then ship them to Europe because of things like exchange rate risks, transport costs, but also because they may want to build local supply chains in Europe. So the issue there, for example, is with China having such a massive cost advantage at the moment, will they continue to make cars in China, or when they penetrate European markets, which they will in 5 years' time, will they follow the Japanese and the Koreans to Europe to set up production here? I think ultimately they will, but the question is still out on that one. What we've also seen, of course, is rising costs of development. So unlike other mature industries, the cost of actually developing cars has actually gone up, linked to new regulations, health and safety, for example. So Ford, for example, may have spent up to €1 billion in developing its latest Ford Focus. Now, it's then got to recover the cost of that development and spend it on developing a new car. That means that companies, the mass producers, have got to share that technology across different brands and share platforms. The alternative strategy is that companies actually go for a premium market and recover a lot of the cost of development on each model. So there's two kind of feasible production spaces in the industry. Mass producers, the likes of Toyota, General Motors, Volkswagen, or at the other extreme, the premium producers. If you're stuck in the middle, like MG Rover was or Saab, you've got no friends, and frankly it's virtually impossible to survive into the future. And I think the other kind of key driver in terms of production is the role of modularization and how increasingly companies cooperate with their suppliers, passing on more and more responsibility to the first tier suppliers who don't just supply individual components but whole modules of a car. It could be a cockpit, a complete door, an engine, a front of the car, and then the assembler actually puts that together. So it's working more closely with suppliers and passing on more responsibility to them.
So you see in the future then that we are going to see more and more of these top tier suppliers producing the technology that goes into these new vehicles rather than that coming directly from the manufacturers?
I think we're already seeing it, and in fact the most successful manufacturers work very closely with their suppliers in terms of research and development and developing the products that go into their cars, and in some cases even working on the assembly line. So you go to Castle Bromwich, for example, the Jaguar Land Rover factory where Jaguars are assembled. The aluminium cars and the aluminium bodies, the chassis actually comes from a different company. Stadco works with Jaguar on the production line. So it's that cooperation with other firms, both assemblers but also suppliers, which is going to become increasingly important.
And is it going to be the technology changes in cars, is that going to be in features that go into the car, or is that going to be new technology in terms of how they're actually made?
I think the technology changes that we're seeing are across a whole variety of different areas. We're seeing more and more electronics in cars, for example, in terms of computer controlled systems, in terms of navigation systems. Maybe over 50% of the value of a modern luxury car is actually in the electronics in that car. We're also seeing, of course, different powertrains, so a shift away from just the use of petrol and diesel towards more and more hybrids. The role of electric cars in the future, although we don't know how much. In the long run, it's likely to be hydrogen, but between here and there, we're going to see a variety of different propulsion systems. That poses big questions for manufacturers who've got to invest in those different technologies. They can't invest in everything, they've got to take a bet on where the market will go, and increasingly they've got to cooperate with other companies. So we see Peugeot Citroën, for example, cooperating with BMW in the development of more fuel-efficient engines. So we're seeing new powertrains, we're seeing lighter weight technologies, we're seeing a massive effort to get fuel emissions down, greenhouse gas emissions down, and meet new regulations. So regulatory changes are driving a lot of the technology changes that are taking place.
And how is all this going to have an impact on the labour needs of the motor industry?
Well, just as we're seeing companies having to cooperate more and more with each other to get access to new technology and move towards what we call an open innovation model, where instead of doing things in-house, they have to look outwards, then so too they're going to need a much wider mix of different types of labour skill. Workers with skills in electronics, in computing, in developing lightweight materials. So it's a much more complex and more highly skilled labour force that will be needed in the future. And companies, of course, if they try and enter new markets, say in China or India, may well set up assembly there. They may well set up design operations there to tailor their cars to local tastes. That means managing quite a diverse mix of different workers in different locations. The key research and development may be back at one location, design and adaptation may be in another, and then you've got to try and manage those different workers in different places. And we see companies operate in different ways in different markets. So in the UK, for example, with a very flexible labour market, during the recession, companies laid off lots of contract and agency staff and then took them on again when the market picked up. So the plants here tend to operate as swing plants, which go up and down with the cycle. That's different in different countries.
And so is that going to have itself an impact on where manufacturers decide to build their cars?
We're already seeing companies like General Motors trying to get their costs down by playing off plants against each other. And we saw this kind of divide and rule strategy recently where supposedly Elmsmere Port was pitted against the plant in Germany, both forced to try and cut their costs. It looks hopefully like Elmsmere Port has been saved. That's, I think, a good decision because it's a very efficient plant. But it means the top-down pressure from these big companies on individual plants becomes more intense as they're forced to compete to retain production.
And how is the impact of what consumers actually demand from manufacturers going to have an impact on what happens in the future?
I think the most interesting area is actually changing consumer tastes and demand patterns, and that's playing out in different places as well, in different ways. So here in the West, in Europe, we're seeing, for example, the effects of austerity and the fact that we're in part scarred by recession, real incomes are falling. There's a noticeable shift towards more fuel-efficient, smaller cars in recent years. In the booming economies of China and India, where there's a kind of very rich middle class emerging, keen to show off their wealth, then that's a kind of bonanza for some of the luxury producers who are seeing very rapid sales increases there. In the case of Jaguar Land Rover, sales in China are up by over 75% last year. So we're seeing the market play out in different ways in different places. What we can say about tastes in many established markets is that consumers are more green conscious. They would like to see features in the car in terms of better fuel efficiency, obviously linked to high petrol and diesel prices, but also they want better environmental performance, although they're not necessarily willing to pay so much for that, and that raises an issue in terms of electric cars and how expensive they are right now. Those have got to come down in cost before that market really does take off. But one of the key things I think consumers want to see is connectivity. They want to be connected in terms of the internet when they're driving for safety and traffic reasons. We're seeing consumers play also a much bigger role in actually designing the end car. So it may well be that consumers go to a website, design the car that they want to see, right down to the colour of the flag that's on the roof or on the bonnet in the case of a Mini, and then click the button to order it. Now, that then means the car being made in response to the order. That's very different from the traditional model, where companies traditionally have churned out millions of cars in the vague hope that consumers will buy them. In the good years, it's meant that they've made some money. In the bad years, they've made big losses. Now, that isn't a sustainable business model. And ultimately, that's going to have to change. We're going to have to see much more of the made-to-order model that we see in other industries, like in the personal computer industry. That's a big mindset change for many producers.
And who is it who's going to be the winners and losers over the next couple of decades? What kinds of company is it that are really going to survive and prosper in the next generation of the motor industry worldwide?
That's a question that I really don't have an answer to, because it's impossible to predict. If I was able to answer that, I'd buy the shares and invest in those companies. Who'd have thought that 25 years ago General Motors would have gone bust? Things changed dramatically over the last 15 years. What I expect to see is the emergence of some major Chinese players, some major Indian players. Tata is already one of them. We're likely to see different markets work out in different ways in different places. You know, the emergence of a rich middle class in India and China, a move towards more fuel-efficient, smaller cars here in the West, for example. So different producers have got to position themselves in different ways for those different market trends.
I'd like to move on to our second speaker, who is a growing friend of the school. Steve Cropley is Editor-in-Chief for Haymarket Motoring Magazines, and this covers Autocar as part of the stable. And he's also a visiting professor for our MA in Automotive Journalism, and he's also kindly volunteered to chair the session this afternoon, question time. So welcome, Steve. Your talk is Everything's Changing in Automotive Journalism, except its extreme importance to the industry's future. Thank you.
Good morning, ladies and gentlemen. It occurs to me that my offerings are a little early in the proceedings. You haven't really heard how things are going to change, as much as you will. But my message is going to be that whatever change comes, it needs to be communicated, and it will be people such as we are training here and such as work with me in the media who will make the changes. Before I proceed, I'd just like to write down a figure for you. If I can find a pencil. Anybody got a... here we are. It's, sorry about the slightly long-winded nature of this, but it's worth it. $75,991,081 people last year bought a motor vehicle. That's according to one calculator in the industry that I trust. You notice I don't say car, I say motor vehicle. That includes trucks. But the point that I want to make is that every one of those people made a decision. These vehicles were not delivered to them by somebody else making the decision. They made an active decision to go and choose those vehicles. And you'll see immediately where I'm coming from. These people acted according to their influences or research or facts that came to them to make the decision about what to buy. And as editor-in-chief of Autocar and other publications, I represent the influences, and my message to you is that nothing at all, nothing new matters unless you manage to communicate it well. Sir Edmund Hillary would have had a very austere career indeed if he hadn't told people that he'd got to the top of Mount Everest when he did, 50, 60 years ago, whatever it is. On the choices of these 76 million people, the winners and losers of the world's motor industry depend. And you can imagine, therefore, that these companies fight very hard to succeed. And it is at the moment the likes of BMW that are succeeding and the likes of Renault, etc., that are not. And the forces of commerce within these companies are therefore fighting extremely hard to improve what they do. Meanwhile, I should, in the spirit of telling you about change, tell you what's happened in our own industry. Autocar was founded in 1895. It was spun off a Victorian bicycle magazine, believe it or not, by a guy called Henry Sturmey, who noticed these contraptions going around London. And he decided to have a 4-page supplement in his bicycle magazine talking about horseless carriages when there were fewer than 50 of them in the country. And the name Autocar comes from, that was his bet about what these cars would be called. At the time, the terms motor car and automobile did not exist. And his bet was that they would come to be called autocars, and indeed, in the first issues of our magazines, you can see them referred to as autocars, but unfortunately he was wrong. But we stuck with the name anyway. The reason I stress that guiding, informing people is so important, is, as you can imagine, is that if every one of these 76 million vehicles is valued at 12,000 quid, you're talking about £1 trillion a year. That is quite a lot of money. It propels a hell of a lot of innovation. Directly or indirectly, the car industry, transport industry employs something like 1/10 of the developed world's working population, and is a key driver of prosperity across the world. Even now, if the car industry is not going well, things go badly. In Europe alone, we're talking about 16,800,000 cars last year. It's a fantastically important and vibrant industry. Let's look at the decision these 76 million people are now faced with. Or let's look at it as it was 20 years ago. It was easy then. You bought the Ford, the Morris, the Austin, or the Vauxhall. If you had a few quid, you bought a Jaguar or a Rover. If you were a deep thinker, you might have bought an estate version, but that was about the extent of the choice. Nowadays, we did a bit of research recently, and we found that between 1990 and today, the number of models and makes offered has increased by 2.5 times. So, whereas if you had 100 choices in 1990, you now have 250. And within that, the Super Mini class alone, which is the popular class for small hatchbacks, used to be 10 entrants, now it's 30. And by the time the Chinese and Indians get going, and they're very ambitious, it will be 40. 40, instead of buying a Ford Fiesta, you have 39 other cars to consider. let's say that you are buying a Golf today. You've made the sensible decision, straight down the middle, bought a Golf. Trouble is you have to decide between a hatchback, a saloon, an estate, or a convertible. Then there's a coupe offshoot called the Scirocco, that's 5. Then you have to decide the equipment level. You have the base model, the design, the match, the Blue Motion, the Blue Tech, the GT, the GTI. There are 6 engines offered. There are 3 transmissions offered. BMW even has 2 separate kinds of steering for its cars. So you can see that the business of informing people, if you do anything that innovates and implies fragmentation, you have to tell the world about it. Otherwise, people will not know the decisions that they're required to make, and they certainly won't be able to make them. So what I'm trying to say is, in the motor industry, in the innovation business, you need to be talking to the likes of us. It is always said that, for instance, your designers, Coventry University has a high reputation for training car designers. One of the things that David Brown and his ilk have always said is that there are 2 customers, and the person who buys the car from the showroom is, in fact, less important than the person like Sir John Egan in his former job, where it was necessary for the designers to go to him and convince him to spend £1 billion on a new model. That's where the first piece of communication and salesmanship comes from. This is where my own craft of automotive journalism, I would say, has an increasing role. As I say, for 100 years we were a magazine. Now we are a thriving website. Probably the website is now bigger than the magazine. We also have 16 foreign editions. Our magazine is translated into Japanese. One of the diversions of my week is often getting a phone call from somebody in Japan wanting to know how to translate. I refer to my wife occasionally in a column I write as the steering committee, and in Japan they don't really know how to translate that. So, some of our jargon falls on, or was found difficult in China, Japan, and India, but we go there now. We have tremendous international audience, and it is from people who want to know what to think, they have to be informed. I believe that impartial experts have never been more important to the health of major industry as they are now. And I hope that you will see, therefore, that the important role that the Coventry Automotive Journalism postgrad course is playing. I was explaining earlier to the Vice-Chancellor that I believe that I think we've probably trained something between 40 and 50 people so far in 10 years. About half of those have found permanent work in the industry. It's tremendously difficult to get into our business. We never place an advert in the paper. We do things we hire the people we know are good. And I think, so what you can say is that by being trained at Coventry, you are halfway to finding a berth in a very difficult, or a job which is very difficult to get into, and that is a major advantage. Just talking about the complexity, the complexity of the whole industry, we see it at first hand. Every week there'll be 5 or 6 car launches of some kind. There'll be either a launch of a completely new model, there'll be a midlife change, which is just as important because it needs to stimulate sales. There'll be, very fashionable at the moment, is the launch of new engine variants, because as clean air laws encroach, cars need to get cleaner. All of these things need to be assessed and impartially reflected upon, I guess. The difficulty for the industry, of course, is that because there are nearly 3 times as many cars on the market as there were, in a given time frame, there is a third of the airtime there used to be. The complexity of explaining new concepts increases, and so the point is that this has to be done adroitly and by professionals, I believe, which is why we thrive, I guess. As the share of airtime drops, advertising becomes more difficult as a medium because it fragments. It's difficult to know which television channel to put your ads on because fewer people watch TV and there are more TV channels. The solution, I believe, is to talk to the influencers and allow them to help to get some sort of a bandwagon going, create a groundswell of knowledge. I am a lifelong believer. I've been in this job 40 years. I've seen communication done very well and very badly. And I just thought I would perhaps talk for a little while on some of the examples that I've seen. One of them came across my desk yesterday. There was just a rather trivial email about a program that a competition that McLaren is running, and there was simply a line that said, 20 lucky winners will meet our test driver Gary Paffett. And this immediately got my back up because I thought to myself, this is actually 20 patronised winners will get to meet Gary Paffett. McLaren could not function, Grand Prix racing could not function, Gary Paffett wouldn't have a career, and Lewis Hamilton would be making less money than any of us in here if it were not for the fact that these people, the audience and the millions around the world, bother with Grand Prix racing. And McLaren, being a rather insular organisation, has used a solitary word in a piece of communication which has said, I believe, the wrong thing. It is so easy to mess things up. I'll give you another example. I was talking to a German company which is about to launch a sub-super mini car. And they were explaining, it was a very nice looking little car. This was last week. And I thought, my wife and I have a history of small cars. We bought a Smart before they were on sale officially in this country. We have a Fiat 500 now. We are thinking of buying something similar soon. And I was looking at this car thinking, suitable for us, this machine. And then out came a marketing bloke who started telling me that their main target area was young people. Now, I'm 63. I can pay for a car. I can buy it on Saturday afternoon if I want to. I know damn well that many people who are 25 can't do that. And so I felt sort of passed over. And I found myself thinking, well, to hell with them. You know, if they don't want to be my friend, I'll find someone who does. And my point is this, that a extremely talented collection of designers and engineers spent 4 years putting that product together, and I dismissed it because of a sentence. And there is no greater, I believe, demonstration of the power of and importance of good communications than that. There is a point, believe me when I tell you this, there is a point in every project where communication is even more important than either design or engineering. And I've seen it happen so many times. I also point you to the legend or the story of a gentleman called Richard Parry-Jones, he's now one of Britain's eminent engineers, an advisor to governments, extremely well known, very successful and rather wealthy consultant. He started as a young engineer, he was a young engineer in about 1990 at Ford, and he realised that the cars that Ford were making were rather poor. The family cars didn't drive very well. They were efficient manufactured products, but they did not drive well and they didn't have much driving appeal. And there was a great deal of sales impetus to be gained by making them nicer to use. The trouble for him was that he couldn't get this message either to the management or to his engineers, the guys that worked in the teams he was trying to set up to improve these cars. So he set out to appeal. He's a man of, I think you probably know him, Sir John, he's a man of great communication skills. He can talk, he's a wonderful talker. We should get him along here sometime. And he got hold of a bunch of journalists, one of which was me, and put his case to us in such a compelling way that we wrote him up. And suddenly, because these stories about him and his aspirations started to appear in the wider press, the management took notice and the engineers took notice. They, in effect, read it in the paper. They believed him. And from that time, Ford started to build better cars, better engineered, better to drive, and they do it today. They have a high reputation now for building some of the best driving cars in the business, and it goes back to a communication exercise by Richard Parry-Jones. Sure, he had the skills, and so did his colleagues, but until they were able to understand the importance of the job through the press, it didn't work. One or two other examples. It was interesting that you spoke about BLMC and some of their cars. I went to a lot of BLMC launches, and that company was known quite well for innovation, but it was also known for not having the product ready by the time they went on the market, and they would spend the first year allowing the early buyers to be the testers and come back with warranty claims and have things repaired, and downstream somewhere the cars would improve. And I can tell you from first-hand experience that the Austin Allegro, much reviled and laughed about, was actually quite a good car at the end of its time. The trouble is the communication, not only from underconfident PR men at the launch, but also communication through the pages of the Daily Mail when yet another engine fell out, was too much for the cars, and they were never successful. In the end, some of them deserved to be successful, but they never were. And it was all a matter of communication. I like to think of, I was taught a very important lesson many years ago. I got to know the Irish flute player, James Galway, a little bit when I still lived in Australia. And I remember he had done a 6-week tour of Australia, and his last concert was in the Sydney Opera House it was an afternoon concert. And he played a program, and then he played an encore, and he played another encore, he played a third encore, and they were still shouting for him to come out again. And he came out for the 4th time and said, "Look, I have to get the plane, but I'm going to play once more for you." And I don't know if you've seen him, but his party trick is to play 2 competing tunes on tin whistles at once, so that these 2 instruments harmonise, and it's a magnificent thing to see. But before he played, he said, "I've had a wonderful time in Australia, and I want to play this last number for the people who have been so nice to me over the last 6 weeks." And then he said, "But it's not for all of them." And there was a hush. He said, "It's for each of them." And I think that business, that audience of one thing, that business of being able to realise individually who you're trying to work for and who you're trying to communicate with and who you're trying to impress is terribly important. And it's important for engineers, designers, for anybody that's doing anything almost. The last one, you may think, I'm going to end shortly, but you may think that this is going right over the top, but I am an enthusiast of communication. I think I've possibly put that across. And I think that one of the most remarkable things ever was something done by Winston Churchill. He had been Prime Minister for 4 weeks, and he had to go to the House of Commons and tell the country that it was probably looking at some years of total war, having been in another war that decimated the youth of the country only 20 years before. And he said, he had a half-hour speech, 20 pages of text, but the last sentence is the one that you can probably remember as well as I can. "Let us brace ourselves to our duty and so bear ourselves that if the British Empire and its Commonwealth should last for 1,000 years, men will still say this was their finest hour." Now, the thing I always say is, that is one sentence. The sentence he could have said is, "Come on, everybody, let's try really hard." And instead, he produced something which was important probably as important as a 5 squadrons of Spitfires or the victory in El Alamein or the Battle of the Atlantic or whatever you like. It is something that helped to bring the Americans into the war. It is something that sustained the country for 5 years of war. It is still a qualifier, I believe, when it comes to being British. It is a really, really remarkable sentence, but it is just a sentence. And my message, as I say, is that whatever innovation you contemplate, that is the power of bothering to tell people about it is terribly important. Not only bothering to tell people about it, but doing it in a very, very good way. That's my message. Thank you very much for listening.
Thank you very much, Steve, for so succinctly, I think, summing up the complexities of the industry. And I found it personally refreshing to hear, I think, an entire talk which emphasised good communication without once mentioning the B word, branding. So thanks for that. Our next speaker is Peter White, a homegrown professor of thermofluid dynamics in our Faculty of Engineering and Computing. His talk is entitled Carbon Reduction and the Influence on Automobile Design. And Peter will discuss the contribution that the automobile must make to reduce emissions and the development of powertrain, fuels, vehicle types and their construction. And Peter will also explore the ways in which vehicle ownership and behavioural attitudes will need to play a part. Peter.
Good morning, everybody. As Martin said, I'm an engineer, and what I'd like to do is to look at some of the engineering drivers for future automobile design. And having listened to Steve, there is certainly going to be a very, very worthwhile and essential job for the communicators associated with the automobile in order to ensure that the right type of vehicle is designed. That's just me. What I'd like to do is to set the scene and say why we actually need to change the sort of vehicle that we drive. I'd like to look at some of the underlying engineering principles. Where does the energy go from the fuel? What can be achieved? Look at some aerodynamic factors, effects on design, driver attitudes, and then for budding designers amongst you, what the challenges are, and then a little footnote. So in terms of setting the scene, the total energy usage is a very large number, 4.2 times 10 to the 20 joules per year. Of that, the US consumes 24%, whereas the UK consumes 2.4%. To put that into a little bit more context, it corresponds to something like 120 kilowatt hours per day per person in the UK. So a 1 bar electric fire on for 120 hours is the amount of energy that we consume. The world average is only 47 kilowatt hours per day, which emphasizes points that have been already made about the developed world and the amount of energy that it uses compared to the developing world. And quite rightly, the aspiration of the developing world is to become the developed world. So we're heading to use even more energy unless we can make everything that much more efficient. Currently, the US has about 4% of the world's population, which demonstrates again that energy usage is heavily skewed towards the developed countries, and it's actually almost a linear function of GDP. This is a graph which, on the vertical axis, it's looking at CO2 concentration in the atmosphere, and along the bottom is a timeline. And you can see that for a considerable amount of time, it's been level. And then it starts to rise gradually and then very, very rapidly, often known as the hockey stick effect. And the point at which the curve turns, if you can see on the right-hand side an expanded version, it's around about 1769. And for those of you that have done a little bit of history, that corresponds to the Industrial Revolution, start thereof, when we were able to harness energy in coal in order to produce steam, mechanical energy from that, and channel it into production. The lower curves show that this also corresponds to increase in coal production, steel production, ships, and population. So as we use more energy, we become more productive and produce more CO2. Now, in 2000, world emissions of CO2 were about 34 gigatons per year, and for a population then of 6 billion people, this is around about 5.5 tons of CO2 per person per year. Currently, Europe emits twice the world average. The US emits 4 times the world average. So we're in Europe on about 11 tons of CO2 per person per year. In China, it's currently 5.4 tons, and in India, only 1.5 tons of CO2 per person per year. And it's been predicted that a doubling of CO2 would increase global mean temperature about 3 degrees Celsius, which corresponds, depending on where you look for the information, of sea level rises from 2 to 6 meters. And when you consider where most of the world's population lives, this is going to have quite a catastrophic effect. And I think the Sindh province in Pakistan is still underwater from last year's rains and floods, and it's just going to get worse. And at one IMEC conference I was at, looking at how to reduce CO2 levels from the automotive sector, we actually decided that the best thing to do for our children was to buy them a surf shop in Milton Keynes, because this was probably where the sea level was going to be in a few years' time. To prevent this sort of temperature rise by 2050, the average world emissions have been estimated that the reduction needs to be down to 1 ton of CO2 per person per year. And if you recall the previous slide, this is less than India is currently emitting. And we want to do this and still maintain our standard of living. So for the UK and Europe, it's a reduction of 90%. For China, a reduction of 81%. And for India, they have to reduce by 33%. And we've heard already where the largest market for luxury cars is. It's China and India. Something like 24% of world emissions are attributed to the transport, and in the UK, 54% of transport emissions are from cars. And from 1990 to 2007, our emissions actually went up. So if there is going to be a significant reduction in CO2 emissions, the automobile actually has to make a contribution. It's not an option. Well, before we start deciding how to do this, from a design point of view, we actually need to look at where the energy goes. This slide looks at the energy distribution in an internal combustion engine powered car, and 100% is the fossil fuel that we put into it. Now, the engine area takes something like 74 to 75% of it, which is exhausted and is heat in the exhaust and the cooling system. Parasitic losses are about 6 to 7%. These are in urban driving conditions. 4 to 5% is lost in the powertrain, and idle accounts for 6%. What gets to the wheels is about 14 to 16%, of which 4% is aerodynamic, 4 to 5% is rolling resistance, and 6 to 7% is associated with the inertia of the vehicle. On a motorway, the balance changes slightly. 20 to 26% at the wheels. The aerodynamic contribution is 13 to 16%. Rolling resistance, more or less the same, 6 to 8%, and inertia, 2%. The reason that the inertia is much lower is that while you're on a motorway, there's not, hopefully, so much starting and stopping. However, as traffic volumes increase, this is not becoming quite so true. If we just look at the energy dissipation at the wheels, we start to see a different sort of pattern emerging. For urban, if we look at aerodynamic losses, under urban conditions, it's about 30% of the energy at the wheels, but on the motorway, it's about 60 to 65%. Rolling resistance is around about 30%, and inertia, that's the amount of energy that's dissipated associated with accelerating the vehicle, about 40% under urban conditions and 8 to 10% under motorway conditions. So if we take this information and say, what does this mean to an engineer who is going to design a vehicle, then it is suggesting that it's very, very difficult to design one vehicle which is going to be optimum for urban driving and for motorway driving. And this is something that could affect the driver attitude in as much as they might decide that they need two vehicles. If that's the case, you can optimize each particular type. What can be achieved? Well, if we reduce mass, we reduce the energy expended on inertia. And on one of the standard driving cycles, the new European driving cycle, an 80 kilogram reduction equates to a reduction of about 3 grams of CO2 per kilometre. And this is information that Volvo put out a couple of years ago. And another thing where driver attitude and driver behaviour and passenger behaviour comes into this is that, and it's a case of do as I say, not as I do here. If 4 overweight people get into the vehicle, the 80 kilograms that the designers and the manufacturers have put a lot of effort and a lot of money into taking out of the vehicle, you've just put back into the vehicle. Aerodynamics, a 10% reduction in the coefficient of drag, again, equates to 3 grams of CO2 per kilometre. That sounds quite good. It's about 3% in each case. But if you were just going to reduce the emission level by reducing mass, there wouldn't be a great deal of vehicle left by the time you got down to the sort of levels that we need to be aiming at. And the aerodynamics would mean that it was a very, very odd shape, and you'd probably be lying flat on your stomach in something with a very low frontal area. Tyres. Around about, as we saw, around about 20% of the energy is attributable to tyres. And there are plans afoot to halve the rolling resistance. Another way that you can do it is to, in terms of the rolling resistance, is to go for narrow, much more rigid tyres. This affects the way the vehicle looks. The low-profile tyre, very broad, gives the impression of power, which a lot of people want to associate with the vehicles and indirectly themselves. This is not the way to go if you want to reduce this 20%. I'd also say that what you can do is actually blow your tyres up and check the tyre pressures. It's something that very few people do. They say, oh, well, I just look at it and kick it. With low-profile tyres, it doesn't make a great deal of difference to the look or the sound as the tyre pressure goes down. And when it does start to make a difference, the tyre's about to fall off the wheel. So it's very, very unsafe indeed. And somebody from a tyre valve manufacturer said that if you don't check your tyres other than at the annual service, i.e. you let somebody else do it, a car with the correct tyre pressures at the beginning of the year, by the time the end of the year comes, the effect of the gradual leakage of air will mean that you've added 20 grams of CO2 per kilometre to the emissions of the vehicle. So again, you can completely negate the engineering effort and the company expenditure, which Sir John mentioned is not inconsiderable when you're developing a new vehicle. You can negate that just by poor driver attitude. Aerodynamics, an important feature. Aerodynamic drag consists of two things. One is the friction of the air moving over the surface. That, however, is a relatively low proportion of the overall drag, as you can see from the figures there. And the other is pressure drag, which is associated with the airflow separating from the vehicle, and that's why you need so-called aerodynamic shapes. And I think we're going to hear some information from Jeff LeGood about aerodynamics and the sort of effects that it has. So I'm not going to go into detail. But if you're going to reduce the aerodynamic drag of the vehicle, you've predominantly got to go for the shape of it. So effects on design of all of this. The design targets have got to be low mass, especially for urban use. Low mass implies lightweight materials, very clever structural design to meet all of the regulations, a low vehicle size. To reduce the aerodynamic aspects, especially for motorway use, we need not just a low coefficient of drag, but a low frontal area of the vehicle, because it's the product of coefficient of drag and frontal area that relates to the opposing force on the vehicle. That's why a train is very efficient, and uses a small amount of energy per passenger kilometre, because everybody's sitting behind each other. And so the proportion of the coefficient of drag times the frontal area of the train associated with each individual is small. A motor vehicle is never going to achieve that. It would look very odd. It would be rather like not a tandem, but a polyden, where everybody in the vehicle just sat behind the person in front. We need low fossil fuel requirements. So low aerodynamic drag, low rolling resistance, low inertia will contribute to the small amount of energy that we need. But we've got to have innovative powertrains in order to achieve that. So the consequences, I've mentioned some of them: small vehicles with lightweight structures, small frontal area per person, narrow, less compliant tyres, downsize the engine, switch to a different energy source. Electricity is not a fuel, it's an energy carrier. So if we're going to look at EVs, and there's examples behind me, if we're going to look at EVs, we've got to look at an alternative means of generating the electricity. Currently in the UK, because we rely so heavily on fossil fuel, every kilowatt hour of energy that we produce in the form of electricity, it's equivalent to 500 grams of CO2. And you have to factor that in to the complete energy conversion train from the fossil fuel through to the wheels of an electric vehicle. If we can go down the route of decarbonising the electricity generation, then EVs or hydrogen vehicles, because they will be getting their electricity, their hydrogen probably from electricity as the energy source, then we stand a chance. I've mentioned EVs, I've mentioned hydrogen fuel cells. My feeling at the moment is that the technology is at a relatively early stage, and I wouldn't like to put my money on one of them in particular. And we do have to bear in mind that this is I'm just talking about cars, if you like, not talking about trucks. For trucks, the electric option is not an option for a truck, because you'd never be able to carry the amount of batteries, especially for long-haul trucking. So we're going to have to look at synthesizing liquid fuels for those. Driver attitude. It may be, as I say, that you need two vehicles, one for urban, one for out of town. 78% of trips are 10 miles or less, and the average daily distance travelled is 30 miles. So, EVs, small hydrogen fuel cell vehicles, all have great potential in filling that need. Drive less aggressively. Roaring up behind something in town, slamming the brakes on, may help you to feel macho and aggressive, but it's not doing a lot for fuel economy. I would say everybody in this room currently has a mobile phone. The vast majority of you are probably on different packages. Why not buy a transportation package rather than owning one vehicle? And your package depends on what your pattern of usage is going to be and how much you want to spend. You may have a small EV for town use, which is perhaps say 60% of the weekly usage. You may then want a vehicle that you're going to use for longer distances, transporting the kids, going to the garden centre, whatever. And depending on how much you're prepared to pay, this could be a medium-sized current car, it could be a Ferrari, it could be one of the ones that are out on the square at the moment. But it is a change in attitude that is required in order to deliver some of what I've mentioned. Choose a vehicle for its functionality, not its 0 to 60 time. And I think it's changing attitudes like this that the task of people like Steve Cropley comes in order to help to achieve this. The designer challenge is to take those engineering drivers and produce a vehicle which appeals to the driver and has an acceptable cost and still gives a return to the manufacturer. We've heard how a lot of small vehicles, and we heard about the Leyland Mini, lots of them made, no money made. Another challenge is to produce the small, lightweight, popular vehicles at an acceptable cost, but which also give an acceptable margin. The designer needs to produce a vehicle that assists marketing and the publicity people to help change driver expectations, especially for urban transport. You don't actually need 250 brake horsepower to travel at 20 miles an hour in an urban environment. And I've got a vehicle like that, and it doesn't do many miles to the gallon. I have another vehicle which has a 0 to 60 time of just over 5 seconds and is considerably more economic in terms of miles per gallon than the 250 brake horsepower vehicle. It's because it's a very light vehicle. It's a Westfield for those that know the make, and great fun to drive, very, very light, and very economic. Thank you. What I'd like to say is to acknowledge the origin of the graphs from a book, Sustainable Energy Without the Hot Air. It's a free download, and for those of you that are interested in looking at the overall energy picture, it's a very good read. Thank you.
Thank you very much, Peter, for so clearly spelling out the difficult challenges that lie ahead, but also, I think, spreading the load of responsibility at corporate level, governmental level, and not least at individual level. Our next speaker follows on quite neatly from some of the points Peter was making. John Jostins is Professor of Sustainable Transport Design at Coventry University, and he's founder of Microcab Industries Limited, which produced the model that you can see behind me. John is actually the only genuine hydrogen head I know, and he's going to give a talk entitled Prospects for New Mobility. He'll talk about the Microcab project, life without oil, and he'll focus on the potential of the digital sphere for integrating and managing our future mobility needs. So, over to John. Thank you.
Thank you, Martin. Good morning, everyone. Thanks for coming, and thanks to the organisers for inviting me to speak. And good news on climate change. It's better today than it was yesterday, so that's important as well. I'm really probably talking more about mobility than cars, because I think that that's the car gets us around a lot, along with lots of other things. I think it's very, very important. I've always worked under this banner, Life Without Oil, so probably the first place to go would be to look at the oil. And this is a poster from an organisation which looks at the study of this. I've just put some extra flags on there. 1860, Pennsylvania, America, oil found in the ground, of course. But a long time passes. Lots of things happened, of course. I'm not saying nothing's happening there. 1913, the reason I flagged that date up is because that was really when Henry Ford put together his process for manufacturing steel cars in large numbers, mass production of the car, and that really locked us in. And I think it's very, very important to remember that we've been locked into that ever since. The next date I show on there is 1970, and that's when American oil peaks, and the blue shaded portion at the bottom is American oil. And then we move on to the sort of today picture, and each time I do this talk, of course, I move that 2012 a little bit further along. I'm running out of places to go with it. Now, I'm not going to say that oil has peaked or whatever. We can discuss that till the cows come home, but it's a sobering thought. And we can see there that the classic thing with the American oil is that it grows to its peak and it falls away almost symmetrically, which wasn't a widely held thought. The sand-coloured area is the Middle East, and of course. So we have a world energy scenario with an energy gap coming. We have all kinds of issues, politically largely, which affect the price of oil, and it's a very difficult scenario to work around. So we've got a lot of problems in here, and we, of course, as has been mentioned, we've got the CO2 problem as well. Going then to microcap. What is microcap? It's a SME, small company based in Coventry. Coventry University is a shareholder. And as you can see on the right-hand side, we've done a range of prototypes, all hydrogen fuel cell, over that time. Prior to that, did work a little bit with electric drives, but my thought was to move away from the internal combustion engine completely, not to think about hybrids or other mixtures. And then, culminating in this vehicle behind me, the H2 EV. This was a new design based on all the prototypes we'd done before, trying to bring together all the knowledge, all the information into one place and say, well, where would we go now? What would we do now? And we considered that we would like to work on an open platform concept, a sort of under tray, a chassis, if you like, which could be powered by a number of things. We don't know really how the world's going to unfold, so I wanted to have that open platform concept. We also wanted to have something that we could work towards EU whole vehicle type approval, and that's because there are regulations to be met, and if you wanted to go further with something like this into production, then you'd need to at least meet those regulations. And we potentially this vehicle could be built in up to 5,000 units a year. The platform as it stands, it could be a light van with a 200 kilo payload, and that's because we've been working with Royal Mail on some previous designs, or a compact taxi, which is why it's quite tall, wheelchair accessibility, and these are 4-seat cars. The Lotus, underneath each of them is a Lotus chassis. This is the standard Lotus method of making a chassis, which is laser cut aluminium, bonded together, baked in the oven. You can also see in there as well, in the middle picture, the crush cans is part of the crash structures that we've built in there as well. There's side impact and front offset impact, and then the last picture shows this double-skinned composite top, which makes up the final part of the structure, giving us an overall vehicle weight. I mean, we're keen to keep the vehicle weight really low. This actually is the heaviest vehicle we've made, largely to do with the crash structures in there. Now, of course, underneath, it's a very, very different powertrain. We have a hydrogen storage tank, which we can fill from a pump, a fuel cell, 3 kilowatt fuel cell from Horizon. We're hybridizing into a lithium battery pack, twin motors, a single speed, and a top speed of 55, so no discussion of 0 to 60 times there, they're not needed. We have a raft of vehicle systems and safety systems on there, which are partly driven by regulation and partly which we've been developing ourselves. and these vehicles are road legal. We have a small fleet. I'm going to skip through those quite quickly. We have been in trials already, but I just wanted to say that we're going into a European trial, which is going to be great because it's going to join up ourselves, Belgium and Germany, new fuel stations, hydrogen filling stations, and 3 manufacturers of vehicles, all small kind of non-OEM manufacturers, and of which we're a part of that program. And we've had a lot of interest in what we're doing from different places in the world, and I mean, South Africa is something that I'm currently, having visited Cape Town last month, working on quite hard. Now let's look at the wider context for hydrogen. You know, how real is it? Well, it's been mentioned a couple of times. It sort of lost favour about 5 years ago when the electrics were sort of coming through. It was like, well, no hydrogen, where are we going to get that from? It means huge infrastructure and so on. But actually, it has a relationship to renewable power, and that's something that we need to look at. And I think there'll be lots of places where we'll be actually making hydrogen from renewable power in the future. And one of those places is Scotland. Now, I was in Scotland again last 2 weeks ago with the vehicle on show there, and you can see the map there, vast resources of natural energy, and they're very keen, of course, to tap into it. Alex Salmon said the Saudi Arabia of renewables, which is quite a statement, and I think I was absolutely amazed to see the technology on display, and these are the small ones. I mean, the big wind turbines and so on are massive. The top right picture, that is a turbine, but that sits on the seabed, and then below it, that's the biggest 3-pin plug I've ever seen in my life. That is waterproof, it operates on the seabed, and it connects one of those big turbines to the grid. So it's definitely going on in Scotland. I was very, very impressed. And there's a specific case, the Western Isles. Now, you can see the little map on the right-hand side. There's a lot of community wind turbine work, which is rather interesting. It's about social capital. It's not about centralised energy. It means a community can invest via their bank or whatever in building a turbine, and suddenly they've got a stream of money coming into the community. And one of the plans that's going on is then to take that electricity and generate hydrogen from it and introduce a hydrogen transport network across the islands. They have to, of course, import all their oil. It's much more expensive petrol at the pump there. I was told it's like £1.65 a litre or whatever. It's a lot more expensive than here. And it's only going one way, isn't it? I mean, the price is not going to come down. So, could hydrogen replace our current sort of liquid fuel way of fueling cars? Actually, some studies have been done, and it is, you know, potentially it could. But the key thing here is we're at a particular place and time in mobility where so many things are changing. I can't see that actually happening for other reasons. And there are lots of new styles of mobility emerging. Now, obviously, we've got this changing energy structure. We're moving to trying to decarbonise everything, of course, and that includes energy. I want to also look at non-motorised transport, autonomous vehicles, and alternative business models as well. The key thing that joins these things together for me is the connected and the digital world. It's the internet, mobile devices, and so on. And that is making a big change. Let's look at, walking and cycling, particularly cycling. Just looking at London, we've got the cycle superhighways, which some people are a bit cynical about, but they do exist. It's a lot of blue paint on the road. I've been on them quite a bit. But you can see there's quite a lot of usage. The other thing you've got is the bike hire schemes, and again, that relies on a billing system and an electronic system to know whether the bikes are in one location, in another location, or out on use, and so on. And there's a general renaissance, I think, in city centres, Birmingham, even Coventry. We see change, we see a more pleasant urban environment growing, and I think people are willing to go out on their bike, thinking that it might be a little safer, a little cleaner. And I noticed this morning, driving the microcab in, that the 20-mile-an-hour speed limit signs are on the roads. So it must have been in the last week or two that's arrived. So, Velev in Paris, of course, a bike hire scheme there. And Amsterdam, well, we always look to Holland, don't we? Bikes used for 55% of journeys under 4.7 miles. I mean, that's a colossal. I mean, how you find your bike afterwards, I don't know. That's something to be worked out. Now, autonomous vehicles. I'm going to go back in time a bit now. You say, what's that? That's something that I was involved in the construction of for Cold Lazarus, which was Dennis Potter's last film, and that was actually a police car or police tank. And but the ones I want to look at more are these, and this was a driverless taxi. You see the doors open down the right-hand side. This was in the workshop, and then when it was finished, you can see on set on the right, and I say driverless, hovering. Those two guys there, they're helping the driver to get hold of his steering wheels and see out a little, because it's film, you know, it's smoke and mirrors. And similarly with the hovering, you can see the picture on the right. There are wheels there, obviously. We took those out digitally, frame by frame, to make them hover. But that was in 1996. I went to Heathrow this year. I find these little pods running around, driverless transport pods, electric, about 20 pods on the track. You go from the car park to the terminal. They charge themselves over points when they come to rest. They speak to you, you press buttons and they go where you want them to go, and so on. So it's the sort of early sort of stages of what we might be coming to. So that's quite important. Now let's look at car clubs, because we've talked about how many cars we're going to need and how we're going to sell all those cars, and will the marketing people be able to design, or the design people design vehicles that everyone will like enough to buy them. But, you know, do we have to buy cars? The car clubs, and you can see here Bays in London, I'm a member, as a family we're members of a car club, and typically you don't know the other members in there, but the typical usage pattern is 12 to 1, so you need a lot fewer cars if you go to that. By the way, I haven't owned a car since 2005. You decide on the vehicle you need for what you're going to do, big, small, van, whatever. The vehicles are scattered on postcodes. You don't go to meet a human being. You go up with your card, you put it on the windscreen, the doors open, the keys are in the glove compartment, you take it away. You see in the bottom picture, I actually went there on my bike to get the van because it was a little bit further away than I would like. And you book on the internet, you pay by the hour or whatever. Great system. Now let's look at Whip Car, because this is rather different. This is where you do buy your car, then you join a car club and you rent your car out to another user. So Whip Car don't own any cars, they just facilitate you and your car and someone else, maybe nearby you, hopefully, maybe someone you know, and actually you can, for the first time in the history of owning a car, the price hasn't just gone like that as soon as you've driven it out the showroom. You've got a chance to, you know, make a little bit of money back potentially. So one to watch out for. I know that they've grown to, I met the guys from Whip Car the other week, and they started out about 18 months ago, they had 1,000 users, they've now got 19,000 people, so they're growing very, very rapidly. Anyway, in all this, there are huge opportunities for vehicle design, and I think that, I talked about 1913, Henry Ford, and his mass-produced stamped out steel cars with a petrol engine. I think this is the time that lockdown is unlocked. I think this is the time when digital media, design and mobility move and change drastically over the next 10 to 15 years, and we'll see. These are just some examples. The folding car at the bottom, and that's General Motors prototype's been going around as well, the ENV. A mobility scooter with a dog, of course. I mean, mobility is simple. It's me going from here to there in something, isn't it, with my dog. That's not my dog, by the way. But. And the Aptera, I mean, it was never going to work, was it? It was never going to fly. But I heard actually they've gone out of business. But, you know, it's a chance to look at different ways, isn't it? It's gone out of business because people, like has been mentioned earlier, how's that going to stand up to a crash with a 40-ton truck? Yeah, it's a problem. The Raptor, which is a three-wheel stand-on vehicle, which you can sort of scoot about in, and I think we were going to have one here on show, but it hasn't arrived. But anyway, and of course the humble rickshaw with the Asian roots, you know, of which there are many in cities across the country as well, and Europe too. The Twizy, which had a little sit-in Aberdeen, great. I think there's one outside as well, and the Gordon Murray T25 as well. So all sorts of new things going on, all sorts of new ways to think about mobility and look at these devices. And so I would say we're in a very, very open space, a space that allows you and your ideas to step in. We got shortlisted for the Condé Nast Traveller Innovation and Design Awards last month, which came out of the blue. I don't know how we kind of got into that, but we did. And I would say thank you to Coventry University, and thank you for listening.
Thanks very much to John. I'm always fascinated by the microcab project because it seems to evolve, and I think the comment that Peter made earlier about nascent technologies and finding our feet, it's an ideal way of investigating those kinds of technologies as they grow in a real world context. So thanks very much.